So, hello, everyone. Can you guys see me? Can you guys hear me? Can you guys see my screen? Hopefully, yes. Okay. So, today in this class, what we are going to see is we are going to solve questions. Simple as that. Okay. Whatever we have studied in the previous classes, we are going to solve questions related to that. So, good afternoon. Good afternoon. How are you guys? J mains is around the corner. At least what you guys can do is you can take the question paper and try to solve it, the 11th portion, right? Okay, so let's start with today's class. So it is the lecture 3. Okay, lecture, it is supposed to be lecture 3. Let me correct it. Lecture 3. Yeah. Now, what is today's target? Today's target is we are going to solve questions. Okay, so shall we start, or do you guys need a quick revision? Let us see what we studied in the previous classes. A quick revision, okay? So this is our previous class notes. We saw variation of G, gravitational field strength, right? Till this part. We didn't go further though. Till this part we studied gravitational field strength. So we saw what will happen to the value of G, our lovely value of G, which is 9.81 meter per second square. Since class 9th, we have seen, okay, this is the, this is the value which can't be changed, right? But still, now we are studying if we go away from the earth or we go inside the earth by digging a tunnel or something, this value can change. And how will it change? We also calculated the value, right? This, see, this is the most general. If we are going at height h, this is always true type scenario, right? This equation is always valid. But I said there is also one more equation, this one, which is only true when our height which we are going is very, very less than the radius of the earth. For example, the radius of the earth is 6,400 kilometers, right? If we are going, let's say, 100 meters, yeah, 100, what do you say, 100 kilometers. So it is quite less than that, right? So that's where what we do, we use this formula, 10 kilometers as such. Now, what if we go inside the tunnel? If we go inside the tunnel, we are left with the equation. I'll just correct this equation. 1 minus d by r. G dash equals to G, 1 minus d by r, as simple as that. Okay. Due to Earth's rotation, there is also some effect due to the centripetal force that also changes the value of G dash, that is G square minus 2r omega square G cos phi, right? Okay. We also solved a few questions related to the same thing. Now what we're going to do is we are going to solve few more questions, okay, so that you have a grasp. Now, the first question is related to, first of all, Newton's laws of gravitation, right? What is the question? The question is three-point masses, 3-point masses m each are placed at the three vertices of an equilateral triangle of side A. Find net gravitational force on any 1-point mass. Right? I'm giving you 2 minutes. 2 minutes, I think, would be a lot. I'm giving you 1.5 minutes. Okay, 1.5 minutes to solve this question. Come on, go ahead and solve this question. Solve this question, guys. Okay, from JNV, Karim Nagar has also joined. I'm assuming Karim Nagar is near Hyderabad, right? I'm from Hyderabad, so I was from Hyderabad, means I used to live. All right, solve this question. You have 1.5 minutes to solve this question. At least try to draw the diagram. That would be sufficient too. If you're not getting how to solve the question, at least try to draw the diagram. All right, come on. Okay, guys, 30 seconds more. Okay, fast, 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 right? Okay, my turn. Let's solve this question. All right. So there are 3 point masses of m each. Okay. So in an equilateral triangle, three masses are kept. These are the three masses at the edge vertices of equilateral triangle side A. Find net gravitational force on any one mass. Means on any one mass, I have to calculate. This is side is A, and each of them has a mass m. Now, on any one mass, so let's do pinky ponky and select a mass. I'm going with the mass on the top. Okay, the mass on the top. Let's see. This mass is being attracted by this mass, right? Let me give them the names. Okay, first, second, and third. So our first mass, since we selected our first mass, is being attracted by the second mass. So there will be a force acting in this direction, yes or no? So there will be a force acting in this direction, right? Okay, let me just clear it up. Yeah. So there will be a force acting in this direction, attractive force, yes or no? Okay. And again, this direction, and mass 3 is also attracting mass 1, right? Mass 3 is also attracting mass 1, so there will also be a attractive force in this direction. Okay, so let's say this is F13, and let's say this is F1, sorry, this is F12, and that is F13. Okay, F12, and this is F13. Now, first calculating these values, let's see solution. F13 is equals to G. M1 means first mass M, second mass is also M, so M square by distance between them is A ka square. Good afternoon. And then F12 is equals to G M square by A square. Now, what is the total force? Can I say force total is equals to F13 plus F12? Since these two quantities are equal, it will be 2gm square by A square. Is that correct? Is that correct? I don't think so. Why? Because these two are vector quantities, and we can't simply add vector quantities like that, right? What we have to do, we have to have, since these are vector quantities, I'll represent force total is equals to F13 plus F12 in vector form, right? Now, what is the resultant between two vectors? The resultant between two vectors is given as, if resultant is given as a square plus b square plus 2ab cos theta under root, right? Okay. A is the first vector, B is the second vector. If I want force total, that will be given as F12 whole square plus F13 whole square plus 2 F13 cos theta. What is the angle between F13 and F12? So these two forces, the angle between these two forces is 60 degree. How can I say that? Because this triangle is an equilateral triangle, right? So the angle between these two is 60 degree. So I'll mention here cos 60. What is theta? Theta is the angle between, I'll write it down, angle between A and B. Means two vectors, the angle between two vectors is cos theta. Okay. So now force total is equals to under root F12 value gm square by A square plus F ka whole square, right? Plus F13, this is gm square by A square yet again, whole square, plus 2 into F12, it is gm square by A square into F13 is gm square by A square into cos 60 is given as 1 by 2. So what will happen here? These 2 and 2 will cancel out. This is gm square by A square whole square, gm square by A square whole square, and this will also eventually become gm square by A square whole square, right? All these three are like terms. See, can you see that these all three terms are like, so they'll get add up and it will give us under root 3 gm square by a square to the power 2, right? Now, this whole term power square will get out of the under root. Eh, We are left with under root 3 gm square by a square. So this is our total force acting on any mass in that whole system. Force total. Hopefully this is clear. Is this clear, guys? I hope this question is clear. This type of question for a square we also did that, right? For a square we already did, and for a triangle I gave you a homework. Now today we solve this as well. So hopefully this question is clear, right? Okay, let's move on. Now next type of question is related to variation of the value of g, right? So this is the question. I'll first explain you the question, then you can try to solve it. Assuming Earth to be sphere of uniform mass density, which we also assumed while we were derivating, right? If we have this assumption, that means we can use that formula, right? How much would a body weigh halfway down the center of the earth if it weighed 100 newton on the surface? Means if the weight is 100 newton on the surface of the earth and we are going down and down and down, at what point, at what depth the weight will become half? Means 50 newton. So I'm giving you 2 minutes. Okay, I'll be I'll give you more time. 2 minutes. I think it's fair. Come on, solve this. Solve this question. 2 minutes you have. Solve this question, guys. Under 2 minutes. Try to solve it under 2 minutes. So let me explain the question once again. If how much would a body weigh halfway down the surface of the earth? Means if we are going halfway, for example, this is our earth. Let me draw it properly. Let's say this is our earth. This is our whole radius r. What if from here we went to this point, that is r by 2? Okay, we went a depth of r by 2. What will be the, what do you say, um weight of that body halfway down? So you have to calculate the weight. Okay, so try it once. 2 minutes. Try it once. Okay, 2 minutes up. Let's start this question. So weight, I'm solving it right here. The weight is given as 100 Newton, right? And weight is a force exerted by the Earth or any planet. That is the weight. So force is given as mg. So what will be the value of g at the surface? 100 by m. Yes. What we have to calculate? We have to calculate the value of g dash. So on going down, g dash is equals to, and depth is given as r by 2. We are going halfway down, right? So r by 2. So g 1 minus d by r. Substitute the values here. If I multiply m and m both sides, so what will this value be? This will be the weight on going halfway down. So can I say this is, yeah, weight dash is equals to weight into 1 minus d by r. Yes or no? 50 Newton is the correct answer. Very good. Now, W dash is equals to weight on the surface is given as 100. 1 minus D means R by 2 into R. Now, solving this, you'll get W dash is equals to 100 into 1 by 2, that is 50 Newton, which is correct. Hopefully, this question is clear, right? We directly use this formula, nothing else. Now, this is the next question. Again, yet again, we are going to solve a question related to the variation of G. I'm again giving you 2 minutes to solve this question. We have done this question, by the way. Okay, you just have to refer to your notes. First, try to solve it with your means try to solve it without seeing, without referring to anything. After that, if you're not getting it, refer to the notes. Come on, go ahead, guys. Two minutes. Try to solve it. One more minute left. One more minute left, guys. Come on. Less than a minute, though. Okay, let me solve this question. What we have to do in this question, G dash means the variation of G and depth. We have to plot a graph between them, and G dash and height. So, and it is in the question, it is explained what is G, what is H. Okay, so let's see. Let's take our graph first. Okay, this is a graph. Now, this is a graph. Now, in this portion, I'm going to refer to distance from the center. Distance from the center. Okay. In this portion, I'm going to refer, I think I messed it. Wait. In y-axis, in x-axis, I'm going to plot distance from the center. In y-axis, I'm going to plot the value of g dash. Right? Distance from the center and the value of g dash, as simple as that. So let me take an example of yeah, let me take an example by let me draw an earth first. Okay, so this is our earth. This is our earth, let's say. Okay, this is where we live, since we are terrestrial animals, right? Okay, this is the waters where we don't live, since we are yet again terrestrial animals. Okay, so this is our earth. Now what we are going to do is, this is the center of the earth, right? As we go, as we move away, we know the gravitational force will increase. Yes or no? It will increase, it will increase, it will increase. And as we move till this point, till the surface, it will increase. And at the surface, it will be maximum, right? As we leave the surface and go more beyond, this value will start to decrease. Okay. So as long as we are in the Earth's surface, as we are moving away from the Earth's surface, okay, so this point is the center. As we are moving away, it will increase, right? That value will increase, and it will become maximum at when our distance from the center is equals to radius of the earth, or else I can say at the surface, right? After that, it will start decreasing. I also told you the proportionality here. Proportionality is directly proportional to r. As you move forward, it will increase. Here, it is inversely proportional to r square, inverse square law. So this is the graph we were interested in plotting. Hopefully, this is clear. right? Okay, let's move on to next question. I'm giving you yet again 2 minutes to solve this question. At what depth below the surface of the earth, at what depth below the surface of the earth, value of acceleration due to gravity is same as the value of height h equals to r, where r is the radius of the earth. Means since we are going up, okay, the value of क्या कहते हैं, the value of g dash is decreasing. Going down also it is decreasing. So h equals to r, since we are going up, h equals to r, at h equals to r we might have a value of g dash. So how much depth we have to go such that we may get the same value of g dash? Let me explain it once again. Let us go to that earth again. Okay, so this was our earth. As we move away, okay, as we move away from the earth, what happens is the value of g dash will decrease. So h equals to h, at h equals to r, there will be certain value of g dash, right? Now this same value should come when we go inside the earth. Means at what depth d, the value of g dash will be same, right? Hopefully you get the question. Try it. I'm giving you 2 minutes to solve this question. Try this question, guys. Try this question. D equals to 2h. I'm afraid that's the wrong answer. That's the wrong answer, guys. Try once again. Asha, what formula you're using? That is important, right? Do we have to use the approximate formula of height or the actual formula of height? You have to think about it. Okay, just giving you a hint. Okay, try to solve this. 1 more minute I'll give, and then we'll move on to the next question. Suddenly I started glowing, right? Okay. Okay, let me solve this question. So first of all, let us discuss what are the formulas. Okay. So for depth, we have the formula. Sorry, for for depth, g dash is equals to g 1 minus d by r, right? And for height, we have the formula g dash is equals to g upon 1 plus h by r whole square. Now, why are we using this formula? Why not the other one? G dash is equals to, why not this one? G dash is equals to g 1 minus 2h by r. Okay, because the value of height is comparable to the value of radius of the earth, right? It's same as value, so we can't use this. This assumption was for when height is very very less than the radius of the earth, right? But this is not the case. That's why we can't use that formula. We are going to use this formula. Now according to the question, the value of height is given as r, right? So let's just substitute this value. G dash is equals to g upon, this will become, I think, 4. See, I'll substitute r here. R gets cancelled out. 1 plus 1 becomes 2. And 2 ka square is 4. Right? So g dash equals to g by 4. Now, these two values will be same. Now we have to find out the depth at which this g dash equals to g by 4. So I'll just substitute here. G by 4 is equals to g 1 minus d by r. So what will we get? 100. What is 100, guys? Okay. So this will become as 1 by 4 is equals to 1 minus d by r. A little interchange. So d by r will become 1 minus 1 by 4. So d by r. Okay, JNV Kottayam students, welcome to Avanti class. Okay, this will become 3 by 4. So d is equals to 3r by 4. Hopefully this is clear. Good afternoon. Good afternoon, JNV Kottayam. Hopefully I'm pronouncing it right. Now, is this question clear, guys? Is this question clear to everyone? Please let me know. Is this question clear? At h equals to r, the value of g will decrease. G dash will decrease, right? So at what value of d, that same decrease we will find. So we just found out at 3r by 4. Hopefully this is clear. Okay. Now we'll move on to the next question. Yet again, I'm giving you 2 minutes to solve this question. Go through it. Come on, solve it, guys. Pretty simple question. 2 minutes I'm giving you to solve this question. 2 minutes is too much, to be honest. Chal. My turn. Let's solve this question. Pretty simple question. A particle of mass is given as 20 grams. Okay. So whenever you see any unit apart from, what do you say, apart from SI unit, right? You just instantly convert that. So that will be equal to 20 into 10 to the power minus 3 kg, right? As simple as that. Now, what else is given? Gravitational force of 4 Newton means force is also given. 4 Newton. Okay. JNV Mahe. Okay, Karim, JNV Karimnagar. The answer seems to be correct. Very good. Find the gravitational field at that point. Okay. So, for example, there was some gravitational field. A mass was experiencing a force 4 Newton along positive x-axis. So, what we have to study? What we have to find out? Gravitational field, right? Gravitational field is denoted by E. That is equals to force by mass. So what is the force? 4 Newton. What is the mass? 20 into 10 to the power minus 3. 10 to the power minus 3 becomes 10 to the power 3 upon 20. So this is basically 4,000 divided by 20, 200 Newton per kg. Very good. See, I'm very happy that one school has given the answer with the units. So it is very important you always mention the units. Okay, in physics, it's very important to give the answer with the units. Okay, so hopefully this question is clear. Let's move on to the next question. Try to solve this question. I'm giving you yet again 2 minutes to solve this question. 1 more minute, guys. Solve it fast. Try to solve it and give me the answer. Okay. Okay, my turn now. Let's solve this question. Let's just understand this question first. Okay, someone has given me the answer. Gm1m by r square. Okay. Force 1 is this, force 2 is this at points P and Q. Um, I'm afraid your first answer F1 is wrong, but second answer is correct. And third answer, okay, let's see. Let's see what's the answer. Okay. So at points P, this is the point P if you can see, and point Q, this is the point Q, and point R, this is the point R. What we have to calculate? We have to calculate the gravitational force, right? And these are two concentric shells. What does a shell do? Inside a shell, we saw gravitational field and forces are zero. Okay, inside a shell, there is no force, there is no gravitational field. Hopefully, this is clear. Now, for point P, see, it is inside M1. So we'll just solve this question like this. For M1, this is inside, right? This point P is inside the M1. So there won't be any force due to M1. Hence, force is 0 Newton. M2. For M2 as well, this is point P. For M2 as well, this point is inside, right? So hence 0 Newton. So force on point P is equals to 0 Newton. Hopefully this is clear. It is clear, right? Okay. Now, let's talk about point Q. So for point Q, M1. For M1, this point lies outside this M1, right? See, this is the M1. This is M1 and Q lies outside this M1. Yes or no? So what we can say is this lies outside. For M2, it lies inside. So because of M2, the force will be equal to 0, right? But because of M1, since it is lying outside, what is the value of force? We just applied directly the Newton's law of gravitation, force due to Newton law of gravitation. F is equals to G m1. M1, mass of first is here m1. Mass of second is given as small m, divided by distance from the center is b, divided by b square. So our FQ at point Q, this is the answer. Hopefully this is clear, right? Let's just talk about point R. So point R for M1, see, for M1 sphere, it lies outside, right? So outside, what will be the value? F ka value, what will be the value? G M1 M by distance is C square, right? What is the value of M2 for that point? M2, it lies again, yet again for M2 as well, it lies outside. So F will be equal to G M2 M by C square. Yes or no? So total will be equal to F total is equals to, or F on, let's say, what is it called? Q, right? No, it's R. Yeah. F on R is equals to G M1 M by C square plus G M2 M by C square. Now you might ask, sir, we did a question on triangle, right? There was a question on triangle where we can't simply add. I mentioned that you can't simply add M1, M2, right? But here I simply added M1 and M2. Why is that, sir? Why are you doing that? Okay, this is not fair, right? Here it made easy. There we have to calculate a lot. So why did you do that? The answer is, see, due to m1 the force is in this direction, right? Sorry, ulta kar diya. Due to m1 the force is in this direction, attractive force, right? Due to m2 also the force is in this direction. The forces are in the same direction. If the forces act on the same direction, then what we can do is we can simply add them. But in the case of the triangle question, see, let me, yeah, the direction of forces, were they same? They were not same, right? One was acting in this direction, one was acting in this that direction. They were not same, they were having certain angle between them. Hence we can say, we can't add, we had to use, what do you say, vector law of addition. But here we can simply add them. What will we get? Fr is equals to G m by c square gets common, m1 plus m2. Hopefully this is clear, guys. Is that clear to everyone? If you have any problem now, you can type in. Okay, type in and just tell me. Acha, I think you guys are operating under like one guy, someone is playing this video, right? So if you have any problem, you can let them know. Okay, I have this problem. Just type that problem in and ask me. All right, you can do that. So hopefully this question is clear. Now, a same question, I would just like to, remove this, and you have to calculate the force yet again at point P. You have to calculate force at point P. Okay. Come on, solve it, guys. Solve this question. I'm giving you yet again 2 minutes to solve this question. Come on, guys. 1.5 minute more. Gm by 2r whole square. Can I say it is 4r square? Can I say that? 4r square, Gm by 4 square. Okay, the answer is correct. Okay, chalo, let's solve this question. These are very basic question. When you will see in the book na, you will be able to solve a lot of questions now. So just practice them. Okay. Okay, let's solve this question. It's pretty simple. At point P, we are going to discuss at point P, right? So for mass M, the point is outside, right? So there will be a force related to it. That will be, force will be equal to G mass M, right? And at this point, we have to calculate force and small m, let's say, by the mass kept at this point P is small m. Okay. Find net force on mass small m. I'd like to include this in the, what do you say, question. You have to calculate force on that mass. Okay. And what is the distance between them? Cp square. So what is Cp? Cp is 2r square, that is 4r square, right? Point resides inside, right? It is inside. So the force will be 0. For 3m, yet again, that point is inside point. Again 0. So total force will be equal to Gm small m by 4r square. What if I say calculate gravitational field? What if I'm saying calculate gravitational field due to this? Can you do that? Gravitational field at point to P. Calculate gravitational. I'm including in this question, in previous question, also calculate gravitational field at P. Come on, guys, do this. Come on, do this. JNV Mahe. Mahe, I haven't heard of this place though. Very good. Can I say 2r whole square? JNV Mahe? I'm just playing with you guys now. Can I say 2r whole square? Okay, okay. Thank you very much for those quick responses, guys. Okay, yet again, if we want to calculate at point P, gravitational field, that will be force by mass. And which mass do we use here? The mass of the whole sphere or the point mass? We have to use the mass which on which the force is being experienced. Okay, at point P, we kept a small mass m, right? So we are going to use that mass here because small mass is experiencing that force, right? Okay, so that will give us gm small m by 4r square divided by m. So m and m gets cancelled out. The value of E will turn out to be gm by 4r square. Very good, correct answer, right? So hopefully this is clear. In the next classes, we are going to discuss. We discussed force. We discussed gravitational field. Now in the next class, we are going to discuss potential and the relation between potential and gravitational field. Okay. So let me give you an idea what else in this chapter is remaining. In this chapter, potential, which is denoted by a V. Okay, potential V, and relation between E and V, U, potential energy. Also, satellites. You learn about satellites. Pretty interesting, to be honest. When I was in class 11th, I was a fan of that topic. And at last, Kepler's law. We're going to discuss Kepler's law. So these are the topics we are going to discuss in the upcoming classes. So we'll meet after the class. Do you guys have any question? You can ask me. I'm giving you 1 minute to type all your questions and ask me. If you have, if you don't have, just write no, no. That is also fine. So do you guys have any question? Okay, my geography is very, very weak, but thank you for the information. I'll look up to it. Probably visit it though. Just a fun fact, petrol prices are very less on union territories. Do you guys know that? Because taxes are less. Okay. Do you guys have any question? And oh no, if you don't have. If you have a question, just write your question. If you don't have, just write no. Okay. Thank you, guys. Thank you very much. Let's end this class then here. If you don't have any question.